This is Geometry Lesson 11.7. We're looking today at volumes of pyramids and cones, okay? Here we have our pyramid right here. We got a couple people laying around the pyramid here, looking kind of mummified. Anyways, here we go. On the formula sheet, do we have a formula for the volume of a pyramid? Take a look at it. Volume of a pyramid. Yeah, we do. It's 1/3 capital B times H. Now, capital B stands again for area of the base. The H is the height right through the middle of the pyramid. The height right through the middle. Okay, here we go. Let's see. On this one, I think we could do it. Volume of our pyramid. It's going to be 1/3. What's the base area? Hey, it's a square. On this one, it's just 3 by 3. Okay, so 3 squared. Good. Okay, what is the height? The height right down the middle is 4. Okay, let's do that. Here we go. We got 1/3 times 9 times 4. 1/3 times 9 is 3. 3 times 4 is 12. There it is. Volume of our pyramid. Now, what about units? Yeah, on this one here, everything, all the length measurements were in inches. Our volume inches cubed. There it is. Let's take another look at a volume here, volume of a pyramid. Now this one's a little harder, okay? It's a hexagonal pyramid, okay? It's got a hexagon base, okay? Now, I drew on this one, I drew the height right down the middle. I also drew the slant height, which is on the outside. I drew them both to show you that when we're finding volume, we use the height right down the middle. We do not use the slant height to find volume. If we wanted to find area, then we would use slant height, but not for volume. Okay? First thing we got to do is we got to figure out capital B, the area of the base. Now, what kind of base is it? It's a hexagon. Every side is 4 inches long. I tell you what, there's way too much stuff going on in this hexagon, so down below, there it is. I got a hexagon. Every side is 4 inches. Let's find the area. Here it is. Area of our regular polygon. That's the formula I like to use. 1/2 apothem times perimeter. Can we find the perimeter? We sure can. 6 sides. Each one is 4. That's 24. We need the apothem. Let's go ahead and draw it in. Okay, we'll do it in red, dashed. Where does the apothem go from? From the center of the shape to the center of the side. Okay, here we go. We'll call it A for apothem. What does it do to that side? It splits it in half. 2 here, 2 here. How can I figure out the apothem? I need to draw in some central angles. Okay, here we go. Let's draw them in. Central angles. Nice, nice. Yeah, hey, there's 6 of them. Okay, here we go. A circle is 360. We're breaking that circle right in the center. We're breaking it into 6 equal parts. Yeah, 60 degrees each. There it is. Okay, take a look at our apothem now. There it is right there. Look at what it's doing to that 60. It's splitting that 60 in half. Just like it split the side in half, it's splitting the 60 in half. So yeah, I get right here. I get 30 and 30. Okay. This triangle right here that I shaded in, that's a 30, 60, 90 triangle. If you want to, you could do trig. Put your eye on the 30. Do tangent. Okay, tangent 30 equals 2 over 8. That's great. I'm going to do, take the short leg. The short leg is 2. Multiply it by root 3, and I get the long leg, 2 root 3. There it is. Let's do that right here. Here's the apothem, 2 root 3. 2 root 3. Nice, 346. 3 46. Okay, let's go to our formula right here. We got everything we need now. 1/2 the apothem. The apothem is 346. The perimeter right down here, 24. Let's do it. 1/2 apothem times perimeter. Okay, 1/2 times 346 times 24. There it is. 1/2 apothem times perimeter. This is going to give us the area of that hexagon base. There it is, 4152. 4152. Now, we're going to remember that because we need that up top for capital B. It's the area of the base. Let's go back up top, 4152. Here it is. 1/3. Capital B is area of the base, 4152. We got that. And the height right down the middle, that's 6. There it is. 1/3, 4152 times 6. Now watch how I do this. Parentheses 1 divided by 3. That's how I do it. Then I got times 4152 times the height right down the middle. I always put the 1/3 in parentheses. 1/3 base area times the height right down the middle. That's going to be our pyramid volume 8304. Okay, 83.04 volume of the pyramid. How about some units? Yeah, we're going to talk inches cubed because it is volume. Okay, nice. Now, in addition to pyramids, we're looking at cones. Same formula. That's why they're in this section together. Pyramids and cones, they have the same formula. 1/3 times capital B times H. And again, capital B is the area of the base. Now, just remember on this one, the area of the base is a circle, because on the cone, the base is a circle. Here we go. Now, notice what I gave you here. I gave you 2 different heights. I gave you the slant height out here. I also gave you the height right down the middle. Which one do we use? Yeah, the one right down the middle. Okay. Now, we're going to need for our base area, we're going to need the radius because the base area is pi r squared. So let's figure out what half of 17.5 is. Okay, let's go do that. 17.5, cut it in half. There it is, 875. Okay, so the radius is 875. That's the number we're going to need for our base area. Here it is, 1/3. Base area, it's a circle, so pi r squared. Pi 875 squared. Then times the height right down the middle, that's 2020. Okay, great. I'll tell you what, let's do that all at once, okay? 1/3 pi 875 squared times 20. Okay, here we go. Maybe come back. Okay, parentheses 1/3, good. Times, we've got a pi. We've got times 875 squared times 20.2. Let's go double check it. Okay, 1/3, good. Yeah, that's it. There it is. 1/3 base area times the height right down the middle. Here's our volume. Wow, 1619 and a little extra. 1619 and a little extra volume of the cone. Okay, hey, units, we're looking at centimeters cubed. Again, what that means is if I had a little cube here that was 1 centimeter by 1 centimeter by 1 centimeter high, that right there would be 1 cubic centimeter. What we're saying is inside the cone, I can shove in 1,619 and a little extra in that cone. I can shove in that many inside there. Okay, let's go do another problem. Here's a cone now. What's different on this one is they give us the volume. They want us to find the radius. Well, if they give you the volume of the cone, most probably you're going to use the formula for volume of the cone. Let's plug in everything we can. Okay. First of all, the volume, they gave it to us, 2120.58 equals 1/3. Now, do we have the area of the base, capital B? No, we don't. Do we have a formula for area of the base? Yeah, we do. It's a circle. It's pi r squared. Do we have the height, the h, right down the middle? We do. That's 25. Okay, now, algebra. What are you going to do first? I tell you what, I don't like fractions. So what could I do? I'm going to multiply by 3. These cancel. Okay, let's do it. Here it is. 3 times 2120. Okay. 3 times 2120. What were the decimals on that one? Oh, 2120, 58. Okay, here we go. Clear that. 3 times 2120.58. There it is. Okay, nice. 6361. 6361. There we go. Equals, here's what we got left. Pi r squared and 25. Okay, let's double check our 63, 61, 74. That looks good. Okay, what's next? What do you want to do? Get rid of the pi. We could do that if you want. Okay, here we go. Get rid of the pi. Divide by pi here. Divide by pi here. Let's do it. Take that number and divide by a pi. That number there, divide by a pi. Nice. 2025 right on the nose. Okay. 2025 right on the nose. Here's what we got. Okay. What's next? Yeah. Divide by 25. Divide by 25. Okay. We get r squared. Okay. Take that number. Okay. Divide by 25. Yeah. 81 right on the nose. 80. Nice. Root 9 equals the radius. 9 what? Yeah, it's just a length. It's going to be centimeters. Nice. Okay, here we go. Last problem. Yeah, last problem. On this one here, find the volume. Well, they gave us the radius. Oh, but we don't have the height. We need the height right down the middle. How are we going to do it? Yeah, put our eye down here. You see a right triangle. I see a right triangle in there. Which trig function you going to do? Think about it. Which trig? Your eye is on the 15. You see the right triangle. Yeah, it's tangent. Here it is. Tangent of your eye equals opposite, that's 25, over the adjacent, that's the h. Let's go tangent of 15, okay? Here we go. Check our mode. We are in degrees, that's good. Okay, tangent of 15, nice, 0.2679, okay? 0.2679 equals 25 over h. Unknown on the bottom, do the Toby switch. Here it is. We got 25 over 0.2679. 25 over that number, okay? 25 divided by 0.2679. Nice. 93.31. 93.31. 93.31. Okay, we got everything we need. Let's do it. 1/3. Base area. Hey, the radius is 25, so base area is a circle. So pi 25 squared times the height. The height right down the middle. We got that now. 93.31. Let's do it all at once, okay? Here we go. Parentheses, 1 divided by 3. Good. Times pi times the radius squared. Good. Times that height, 93.31. Let's double check. 1/3 is in parentheses. That looks good. We've got the base area, pi r squared. That looks good. Times the height right down the middle. Here we go. Wow. 61,071. 61,071. 61,071 and a little extra. What do you think for our units on this one? Our units, this was in centimeters. Centimeters cubed. Big number. It's okay. Hey, that's the end of geometry. Lesson 11.7. Okay, have a good one today.